Good evening, everyone. In the today's topic, we are going to discuss about the design paradigm in VLSI design. Before that, the small introduction. The course code of the CMOS design is 50EC505, and the module comes under in VLSI design. So first, the design paradigm. The picture shown here subdivided into three domains: that behavioral domain, physical domain, and a structural domain. The design representation space consists of domains and levels. So the domain is classified into three domains: behavioral domain, physical domain, and a structural domain, where the levels of abstraction starting from system level, RTL level, logic level, circuit level, and the gate level. So the behavioral domain most abstract in the domain level subdivision, and the structural domain specifies the architecture, and the physical domain include the transistors and the layout. So these are the three domains in the design paradigm of VLSI. The behavioral is abstract, and the structural domain specifies the architecture, and the physical domain include the transistors and layout. So in the domain level, for the simplification, you will see this diagram. The behavioral domain using the circuit, the Boolean expression for input and output. You will have the behavioral of the circuit, and then the structural. The structural you will have a gate level domain, structural domain, and the physical domain it will be a layout design type of design. So the behavioral, structural, and the physical domain. So next, the levels of abstraction. System level subdivided into different blocks is a system level, and the gate level different gates connected together, it's a gate level, and the register level. So different registers added together, that's register level, and the circuit level, different small circuits together called a circuit level. So in the levels of abstraction, you will have a system level, gate level, register level, and the circuit level. So a typical VLSI design flow is shown here. The different flow starting from the design entry. That's one. What is a design entry? What are the basic design as parameters you have to give in the design entry? Suppose you will have a VHDL or Verilog code, you will give the data in the design entry, and the next step is the logic synthesis. The logic synthesis will create the netlist of the circuit whatever you have given through the coding or VHDL or Verilog coding. So next, the third one is the system partitioning. The system partitioning, after the logic synthesis, will subdivide the system into different partitions. The system partitioning. Next, floor planning. After the partition step is over, you will have a floor planning, placing the partitioned parts into different places according to the connection wires length. The next step of the floor planning is the placement. So after floor planning, placing the different blocks in a IC takes place, then routing. So after placement, connecting the different logic cells is known as the routing. After routing, we'll have a circuit extraction. So extract the circuit. Next, post layout simulation. So you will have three layout simulation. One is on pre-layout simulation, next one is the post-layout simulation. At the beginning of design entry and the system partitioning, you will have a pre-layout simulation. So once the routing is over, the circuit extraction were done, then the post simulation is using. So in the VLSI, you will have two types of design. One is the front end design and one is the back end design, or you can call as a front end design, you can as a logical design. So back end design, it's a physical design. So physical design based on the layout types of simulation or layout design. So in the logic design, you will have a circuit coding. So next is the typical VLSI design flow, the simple explanation given in the slides. So the front end design, it is a logical design, consists of the following steps. The design entry, enter the design in an ASIC design system using hardware description language or semantic entry. Then the logic synthesis. In logic synthesis, the generation of netlist, that is logic cells and their connections from SDL code. Logic synthesis consists of the following steps. There are technology independent logic optimization, translation, that is converting behavioral description to structural domain, then the technology mapping or library binding. The next step is the system partitioning. Divide a large system into ASIC sized pieces, that is system partitioning. Next, pre-layout simulation. So pre-layout simulation, check to see if the design functions correctly, gate level functionality and timing details can be verified. These four steps in the previous slide we have seen in the flow diagram. The design entry, logic synthesis, system partitioning and pre-layout simulation. Once the design entry is over, the logic synthesis is done. After the logic synthesis, system partition is was done, and next the pre-layout simulation. So these type the four steps comes under in the front end design. You can call a front end design can also be a logic design. Next, partitioning. So partitioning means segregating the circuit into two parts. The diagram shown here is a partitioning. So next, the remaining steps comes in the typical VLSI design flow. So you can call this as a back-end design or physical design. The physical design consisting of the following steps: flow planning, placement, routing, circuit extraction, post-layout simulation. The flow planning, they arrange the blocks of the netlist on the chip. The placement is decide the locations of cells in a block, and the routing, make the connections between cells and blocks. Next, the circuit extraction. In the circuit extraction, determine the resistance and capacitance of the interconnect. Next, post layout simulation. In the front end design, you will have a pre-layout simulation. In the back end design, it is a post layout simulation. The post layout simulation, where the check the design still works with the added loads of the interconnect. They are done in this post layout simulation. So the steps in the back end design are flow planning, placement, routing, circuit extraction and the post layout simulation. Next, the flow planning, particularly the flow planning, the entire arrangement of blocks including their cushions are arranged. So the functional module is assigned an outline area so as to facilitate the gate placement. Then the allocation of different pins, that is IO, clock and other control pins of various functional blocks, so that the internal and externalness can be routed in the flow planning. So next is the placement and routing. So after the floor planning, and the partitioning, the circuit into smaller modules and floor planning the layout to determine the block outlines and between locations. So the placement, it determines the locations of standard cells or logic elements within each block. In the routing phase, connection between different blocks is defined. That's all about the typical VLSI design flow, the levels of abstraction, the gate level, circuit level, logic level and the RTL level, system level. Then the three domains, the behavioral, physical and the structural domains. Thank you very much.